Hello everyone and welcome to Statistically Speaking. Today I'm going to go through some symbols that are usually found in different statistics and formulas and stuff like that. They can be either different operations to simplify formulas, or it could be something that we think we know what it is, but in some textbooks and scenarios it means something else. So I'm going to start with explaining this symbol. This is big sigma in Greek letters, I believe, but that's not usually what we say. We often just say the sum of, because this is the sum. So what does this mean? Well, we have this symbol, and often we have something underneath, maybe I equal to 1. It could be another letter, it could be something else. And then above, let's say we have 5. The one that is below is where we start, and the one that is above is where we end. So let's have a simple example. The sum of I, when I equals 1 to 5. What this means is, the first step we put I equal to 1. Okay, that's 1. And then we sum it to the next. And the next is we take I plus 1. So then we get 2. And then we do it again to 3 and to 4 and to 5. But that's where we end because we have 5 up here. And then we can just calculate what is this. And this will give us 15. But that's not usually how we see the sum used. We don't usually see sum of I. We usually see sum, maybe I equal 1 to n of xi. And this I is a notation, so it just tells us which x are we looking at. And if we do the same, we will change I to the number we have. So the first step will be x1 plus x2 plus x3 plus and so on till we get to the last one. And this n could be any number. It could be 5 or it could be 1,000. We have xn at the last step. And this might be, let's say we have a sample. We have taken a few. And we have one that was 3 and one that was 4, and then we have one at 10, and then at 7, and so on. Then the first here is x1, the second is x2, the third is x3, x4, and so on. And we just put 3 here instead of x1, and 4 here instead of x2, and so on. And that is how the sum works. Another operation that is quite common is the product of. So it works very similar. You might have this I equals 1 to 5, and then I. But instead of summing it, we multiply it. So we have 1 multiplied by 2, multiplied by 3, multiplied by 4, multiplied by 5. And we stop at 5 because that is our highest point. And then we calculate this and we get 120. So it's very similar to the sum of, but instead of taking plus, we take multiply. And the same is true when we have I equals 1 to n of xi. It's the same thing. We have x1 times x2 times and so on times xn. It's the same concept. The next operation I will talk about is factorials. Now, In this case, we don't put things behind it like we did with sum and products. Instead, we put things in front of it. So let's say 5 factorials. What does this mean? Well, it means we start at the first number we have, that's 5, times, and then we lower it one step. 4, and then again, 3, again, 2, and 1, and that's it. We stop there, because if we multiply by 0, we're gonna get 0 at everything. So, in this case, 5 factorial and the product of I from 1 to 5 is the same thing, but we move it in another direction. So if we have, let's say, n factorial, that would mean we have n times, we lower it one step, n minus 1, we lower it another step, n minus 2, and so on, till we get to the last point, 1, n minus n. And here is usually where people can get a little bit confused, because it would seem that we're taking a higher number, but we are subtracting more and more. And another thing that is important when it comes to factorials is the special case when we have 0 factorial. We can't have a negative factorial. We can't put like minus 1 factorial. Maybe with complex numbers, I'm not sure, but in normal cases when we use it, we never have negative factorials. But 0 factorials we can absolutely get at some points. And what we define that as is 1. Because oftentimes we have factorials when we divide things at the bottom and we can't divide by 0. So, to solve that problem, 0 factorials is equal to 1. There are some good videos on YouTube that explain why 0 factorials is equal to 1. If I find something good, I will link it in the description below. Otherwise, you can look, search yourself, and you will find something. The next symbol I'm going to talk about is pi. What is most known about pi? It is that pi is equal to 3.14 and so on, some infinity number. And we use it to calculate, I think, like the area of circles and stuff like that, I believe. But in statistics, and probably some other fields also, but the symbol pi can mean other things. In some cases, this pi could equal the probability of some scenario. It can also be the prior in Bayesian statistics. I'm not too familiar with Bayesian statistics. I'm going to learn some more this spring about it. But from what I know, it can also be the prior in Bayesian. I think that's how it's spelled. So if you see pi in some formula, take note if there is some information somewhere that tells you that it's something else than pi. Because in statistics, pi might not be pi. And the last thing I'm going to talk about today is absolute values. Because at some point you come across these when doing statistics and stuff like that. And it's good to know what is it. So when you have something like this where we have 2 lines next to the number or variable, what this means is that the symbol in front of the number doesn't matter, we will get a positive number outside of it. So let's have 5 and minus 5. I will put absolute values next to both of those. the absolute value of 5. Okay, we will take the positive of the number we have inside. Well, it is still 5. The absolute values of minus 5, the positive value of that inside will also be 5. And then when is a situation where we might come across this? Well, let's say that x is going to be larger than 5, or x is going to be less than minus 5. We want the extremes on both sides. Well, we can either write it like this, or we could write that the absolute value of x is larger than 5. Because then we might have minus 7. The absolute value of minus 7 is 7, and that is larger than 5. And that was some explanation about these different symbols and what they mean and how we use them.